Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Test. Can you hear me, guys?
Yes, Mr. Ali, we can hear you.
Start right now for some more participants to join. Okay. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good afternoon to all participants. Welcome to the postgraduate structure course organized by Pgss SKE 2021-2022. The title of the course today is The Future of Engineering, Internet of Things Perspective. The session will start at 2:30 p.m. And now I will explain the rules for the participants. First, kindly keep your microphone muted to avoid any interruption to the presentation. If you have any question during the presentation, you may type in the chat window and keep your video turned off until the group photo session at the end of this course. For UTM students, you will be given an e-certificate and UTM merge in the ICAD system if you fill in the attendance and feedback form, which would be given at the end of this session. Be sure to enter the correct details so we can record your attendance and send you e-certificate and other supplementary materials. Be sure to use the provided materials, including the slides or the recording of this session for your own reference only. And while we are getting ready and waiting for some more participants to join, we expect to start the course within 5 minutes at 2:30 p.m. So stay tuned. Assalamu alaikum, Prof. Rosie, are you with us?
Yes, Ali. I'm here already. Should I share my slides now?
Yeah. No, not yet. Yes.
Not yet. Okay, all right.
Thank you, bro. Thank you. Okay, assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good afternoon to all participants. Welcome to the postgraduate structure course organized by Postgraduate Student Society of School of Electrical Engineering, Pgss SKE, in collaboration with School of Graduation Studies, SPS, University Technology, Malaysia. My name is Ali Othman, and I am the moderator for hosting this session. We are very honored to have Associate Prof. Dr. Roziha Rashid, who will be the speaker to the postgraduate structure course today, entitled with The Future of Engineering, Internet of Things Perspective. A little bit introduction for our speaker. Okay. A little bit introduction for our speaker, Associate Prof. Dr. Roziha Ahmed Rashid. Received her bachelor's degree in electrical engineering from the University of Michigan, Ann Arbor, United States of America, and her master and PhD degrees in telecommunication engineering from the University of Technology, Malaysia, UTM. She is a senior lecturer in communication engineering program, School of Electrical Engineering, University of Technology, Malaysia, and is currently the head of telecommunication software and system, TESS research group. She is an IEEE member and has more than 140 publications, mostly in the area of telecommunication engineering. Her current research interests, including Internet of Things, IoT. She's involved in any, her current research interests, including wireless communication sensor network, connective radio, and Internet of Things, IoT. She's involved in many IoT-based industry projects. To date, she has led more than 20 projects as principal investigators and about 40 projects as co-investigator under various types of grants that include national, industry, community, and university grants. Okay, Prof. Now I would like to pass the session to Prof. Whenever you are ready, please start. You may start your presentation now, Prof.
Thank you, Ali, for the introduction. First, I'd like to correct the profile. I'm not the Director of Communication Engineering Program. I'm just the head of Telecommunication Software and System Research Group. So hopefully somebody can somehow get it corrected. So before I start, I'd like to share my video, and also I'd like to ask permission to somehow shut down my video because I'm stopping my video because I'm working from home now. So the internet might not be that good. So sorry. So can you see my slide? And can you hear my voice?
Yes, yes, Prof. It is clear.
Okay, all right. Let me see. Okay. So I'll put this on full screen. Hold on. Okay. As mentioned, I'm Associate Professor Dr. Roziha binti Rashid, and today's webinar will be titled. The title of today's webinar will be the future of engineering, Internet of Things perspective. This is the outline of my presentation. So it will be divided into two parts. So hopefully you don't mind, because in the second part, I will talk a little bit on my research group. Okay, so I will start with the understanding of IoT first. And since the title is about IoT, future of engineering, so I'll be talking about the components of IoT and their future directions. Okay, so IoT actually has evolved so much from its initial definition, which were sensors and actuators embedded in physical objects that are linked through wired and wireless network. So this is actually was coined by Kevin Ashton 20 years ago, 21 years ago. So now actually the potential of IoT has outgrown its original definition. So it's not new, but it's newer. So with the current definitions of IoT right now, we have many paradigms, smart paradigms in the form of smart home, smart cities, industry 4.0, autonomous vehicle, healthcare and wellness. So as mentioned, initially IoT is just about the monitoring. So it involves the data captured from sensors. So basically we can sum up, the evolution is from telemetry to telematics to machine, and finally IoT, where you have interconnected data that can speak to each other and then can be upload to the cloud server for storage analysis, and can be remotely monitored. Okay, remotely monitor from anywhere at any time, as long as you have internet connectivity. Okay, so as you can see, over the years, the number of installed IoT devices around the world has increased drastically. So as of 2025, we expect to have 75 billion, about 70 billion of IoT devices. And you can see also from the IoT analytics over the years, the enterprise spending on the IoT technologies has also increased, especially in the segment, in the IoT hardware and IoT services segments. Okay, so this is basically the investment of industries around the world in IoT products, or also IoT services. Okay, so and this can be actually seen also in the ratio of connected devices per person. All right, per person. So back in 2003, where the world population stands at 6.3 billion, the connected devices are about 500 million. So if you take the ratio, it's about 0.08 connected devices per person. But at 2020, you can see that connected devices per person reaches already almost 7 devices per person. And now we are at 2022. So I think we can still somehow take the ratio at about 7 connected devices per person. Now, this trend actually has been on the rise since 2007, 2008, where you have more connected devices than people. So what are those connected devices? As of now, actually, many people on themselves, they have the smartphone, sometimes even 2 per person. You have a smartwatch. You might have a Bluetooth earphone. You might have your laptops and so on. So those are the connected devices that are basically carried by a person every day. Okay, so you can see that over the years, actually, how the governments around the world reacted to the IoT trends. So you can see that the global IoT market to surpass 1 trillion mark by 2024. IoT helps to make return to work safer, and so on. There are right now, because we are in the industry revolution 4.0, so we cannot actually not talk about IR 4.0 without mentioning IoT. So when I say the industrial revolution, so hopefully many of you have heard about it. Okay, industrial revolution 4.0. So they say now we are in the fourth industrial revolution, but for some countries like China and USA, they might be moving to the fifth industrial revolution already. But some countries, maybe Malaysia, I would say we are still about the third industrial revolution. So it depends on countries actually. So the first industrial revolution starts when they discover this mechanical, when they actually do have some mechanical constructions and so on. All right. So after that, the second industrial revolutions, more on the when they discover energy, oil and so on. So you have actually the electrical energy also at this point of time starting to have very very progressive, because you have already the first assembly line, Cincinnati slaughterhouse in 1870. All right. Then third industrial revolution involves more with the electronic products and IT products. So this helps to further automate production. And the fourth industrial revolution is through the cyber physical system, meaning that at this point, actually because of the advances in telecommunication technology, so we managed to somehow have a remotely controlled or remotely automated, controlled and automated remotely through the available telecommunication infrastructure. So and then of course, if you can see the progressive years from the first industrial revolution to the second industrial revolution, it took some time. All right. It started like in 1780 and it lasts about a decade later. But from the second industrial revolution to the third industrial revolution, it takes about the same period of time as well. But from the third industrial revolution, with the advances in electronics as well as IT products, the migration from third to fourth industrial revolution becomes shorter. Okay, the time taken for the migration from the third industrial revolution to the fourth industrial revolution becomes shorter. And as mentioned, at this moment now, 2022, some countries already in the fifth industrial revolution, some still moving towards the fourth, still in the era of fourth industrial revolutions. So, but the time, the period, okay, between fourth industrial revolution and the fifth industrial revolution, now I think it's we might be in the fifth industrial revolution, but maybe not for some countries. All right. Why I said something like that? Because as you can see, for the fourth industrial revolution, these are the elements. These are the components of fourth industrial revolution. You have system integration, you have simulation, you have cloud computing, you have additive manufacturing and IoT as one of the enabling technologies, and you have also cybersecurity, autonomous robots, big data, and augmented reality. So what is the fifth industrial revolution? So many says the fifth industrial revolution is on data analytics. So as of now, we have that as well already. And for some industries is already, for some countries as well, like China, they are ahead of other countries in terms of the machine learning and in terms of intelligence, system intelligence, and so on. So, and this because of the fourth industrial revolution that provides the infrastructure as we have now. The migration to fifth industrial revolution is seamless. All right. So why I say right now we are actually maybe already in the fifth industrial revolution. Why? Because from the stages of IoT, as mentioned earlier, IoT is no more just it's not limited anymore to its initial definition. It's not just about real time monitoring or data captured using sensors. You have to have some sort of data analytics as well. So there are like 5 stages of Internet of Things, where the first is just about device connectivity and data forwarding. So this is the, I would say, a very basic IoT. So if you somehow wants to do project just about data capture and monitoring, when you just forward the data to the cloud and then you want to monitor at the user end, you are actually just implementing the first, the basic platform of IoT. And when you have like into the second stage of IoT, you have actually real-time monitoring. So you can actually have data is monitored and visualized. So you have that kind of platform ready and so on. So you achieve some sort of awareness of the equipment status. Okay. And then if you have the third, you are already at the third stage, you have some sort of data analytics. So if you have a basic data analytics so that you can somehow get some insights and predictions and a little bit of automation, then you are at the third stage of data analytics of IoT, the third stage of IoT, which have data analytics. And when you have automation, so this actually will allow you to orchestrate automated complex action from equipment to inventory support, sophisticated and other system to enable condition-based maintenance and better device utilization. And of course, when you reach the fifth stage of IoT maturity, you have onboard intelligence, where actually you can have autonomous operation. Okay, so this actually can be visualized. I can give one example. All right, like if you have a car. Okay, if you have a car. So in order to have the first stage of IoT, how you must have some sort of a sensor and data that is forwarded for you to monitor. All right. So what is the sensor that you can somehow install in your car? Anybody? So GPS, one of it is GPS. Some cars actually comes with GPS already. All right. So once you have GPS, you want to monitor, right? You want to monitor. So you may have a mobile application on your phone. You park your car. You you go to the class, and then suddenly you get an alert, and then you can see on your monitoring gadget like your smartphone or your laptop, your car is moving, but you are here in the class. So something must have happened to your car, right? Like it's being stolen, right? So so you are actually right now you have a system that is at second level of IoT maturity because you can monitor. Okay, so then when it reaches the third stage, basically right now this is actually you have the gadget, so now you see that your car is taken away. You must actually do some analytics, some sort of decision making. Okay, decision making, what to do. All right, what to do. So it's not up to you. Okay, you can have also some sort of manual intervention, but if you have manual intervention, your IoT stages, your IoT system is not mature enough. It is mature when it can do its own decision making, meaning that okay, you can somehow do manual intervention. Says from the mobile apps, you can immobilize your car. Okay, you can. Yes. Any question? Is there any questions? Can I
No.
proceed?
Yes, continue.
Okay, sorry.
Okay, thank
Okay,
you.
so you can immobilize your car, or actually you can already program your car to have like geofencing system, meaning that if the car moves like 10 meters away or 5 meters away from its was parked, then it will stop automatically. So you include some sort of security measure in your car. And then if your car has already the 4 stage, you can alert you when is it due for maintenance, and then when you travel, which is the shortest route that you can go to somehow to save fuel and so on. And then of course, if your car has the higher stage of IoT maturity, which is the 5th stage, you don't need to drive anymore. It's a driverless car, autonomous car, and we have it already. So the future of engineering is now actually, because we have Tesla and also Google car nowadays that has the highest level of IoT stages. So as of now, because we are engineers, I hope most of us are, hopefully. So we like to present things in terms of equation, right? So IoT now is not about just sense. It's not just about sensing. It was before the initial definition. Now it's about sense plus infer plus act. So when you have how to sense, you need sensors. Okay, and in order for the data captured by sensors to be sent to a cloud platform, to be stored and analyzed, you need connectivity. All right, so this connectivity through gateway can be also achieved by using communication network technologies such as Wi-Fi, LoRa, narrowband IoT, or 5G. We'll talk about that later. And then in the cloud platform, you can do some analytics besides storing, meaning that you apply some rules engine and so on, so that the action that perform from the decision making, so to perform the action, is actually derived from having some sort of optimization, machine learning, and so on. So now, this is the IoT ecosystem, or in this case, since we are engineers, I like to call the IoT equations, all right, which include sense plus infer plus act. So this is the future of IoT. So if you see the statement down there, it might you might be confused. IoT is that, long live IoT. All right. So why I say IoT is that? Because initially IoT is just about this part. Sensors and actuators embedded in physical objects that are linked through wire and wireless network. Now, there's a plus there. With this plus, which is the ability to make sense of the data captured and take meaningful actions, you have long-lived IoT. If your system that you develop just stops in the first part, then it's just almost that. Okay, so but if you include this part as well in your developed system, long-lived IoT. Okay, so and the future directions, the things connectivity and future directions. So right now we do not call anymore the things. We like to call it cyber physical objects. So what is cyber physical objects? So I will explain more. So and then sensorizing objects, people, supply chains, and environments to digitize the physical world. So what it does actually, why we call it cyber physical, it translates from the analog data from that surrounds us into digital form. All right, so that is like the connection between the physical objects with the cyber world. So that's why the things right now, with the things and connectivity, we call it cyber physical objects. Okay, so this is some examples where how do you have somehow the things right now does not come as a passive analog objects, but with the active passive sensors, you integrate with processor and also a connectivity module so that you can send the data to a gateway that can bridge between these digital the data that's been captured to the internet so that you can upload to the cloud platform to be stored and processed. So sense from analog to digital. So this is to capture the physical world data and brings it to the digital domain. Okay, the reason you want to make sense of the data. As said, sense plus infer. Why? For decision making. Decision making is the action that comes after processing. Okay, so traditional IP actually normally is not like this. Okay, traditional IP network normally is assigned to each cases, each industries. But in future, I'm talking about future right now, we will look at the network slicing. So what is network slicing? We try to have one network and then we slice it according to the use cases industries. So this is like the what you say, the visualize directions, the future directions of IoT in terms of things and connectivity. We want to have one network that can support all telecommunication technologies, but we need to slice it according to the use cases and industries. One network to rule all. So the reason why we want to do that, the industries want something like that. All right. First, because we are moving towards 5G. All right. So if we have this one network to rule them all, we will have low cost. It is foreseen to have some incur a lower cost, low energy, small data volumes, massive numbers. We can support more IoT devices, IoT networks, okay, at the edge, okay. And then the critical communication, they expect or they predict that it will be ultra reliable, very low latency, and very high availability. So network slicing is the future directions for the things and connectivity in the IoT ecosystem. Maybe we can ask later, the questions later. Shall I proceed? Because I cannot.
Yeah, yes, Prof. You can proceed.
Okay, please stop me if you want. It's okay.
Thank you, Prof.
Okay. So as I see, the convergence of the things in IoT and traditional sensor network. So right now, we have the IoT platform as software as a service on premise. So all these traditional sensor network can be connected via this platform so that it will be stored and analyzed for, as mentioned, some processes that can be performed on this IoT platform, data analytics. And then this is on the user ends where we have the web dashboard, mobile application, customer relationship management, enterprise resource planning, IT, OT integration, customer reporting. So this is on they call it enterprise application. All right. So this can be IoT in general is where the things, okay, the things that is captured by this system, traditional sensor network, directly send the data to the internet. Okay, normally before this, you don't have direct connection to the internet. Okay, so but right now, we will have the sensor network as a super sensor. Okay, super sensor that become an IoT device when connected to the internet. So this is the I would say is viewed as the cyber physical objects because you are translating whatever from this silo sensor network. Right now, you have all integrated into this one platform this IoT as a software as a service platform to be able to be viewed by the end users, and also for decision making, right? Remember that we have info plus action. So, and this is the future directions actually. So we can see that local IoT devices right now will be combined, okay, combined or coordinated using one gateway devices, and then many gateway devices will be combined with wide area IoT devices to be coordinated by the edge IoT devices, and then to be sound, the data captured, all the data that has been forwarded here will be sent to the cloud devices. So the super sensors, right now, the topology is something like this, where you have hierarchy from local IoT devices to gateway IoT devices to the edge IoT devices. This part is called fog computing. And then from the gateway IoT devices to edge IoT devices, edge computing. And then when you have all this sent to the cloud platform, this all together makes it IoT platform, IoT ecosystem. Okay. So the problem, the problems. So standards, all right, standards. So there are situations where you have competing standards. For example, in the cartoon there are 14 competing standards. 14. Ridiculous. We need to develop one universal standards that covers everyone's use cases. Yes. Soon there are 15 competing standards. All right. So there are still issues, challenges to this idea of future things and connectivity. All right, because one of the challenges, as mentioned here, is the competing standards. Okay, so the connectivity will provide the networking and communication capabilities. So normally is divided into or classified into two categories: transport protocols and data protocols. Okay, so the function is to collect, transport, and exchange data over the internet to be remotely monitored and controlled. So this is comparison of wireless technologies. This is for transport protocol. So you can see that you have a ZigBee here. You have Wi-Fi. Where Wi-Fi is here. Why? Because this is the data rate. Okay, and this is the coverage distance. Okay, coverage distance. So if your system or developed system has low data rate and then is for short distance, you might opt for a ZigBee communication protocol. But if your system needs a higher data rate and cover a longer distance, then you might opt for Wi-Fi protocol. All right. But if your system has wants to support low data rate but longer distance, so you might want opt for what is called low power wide area network, where in this part of the communication technologies, you have narrowband IoT, you have LoRa, and also Sigfox. All right. So and then the cellular system. So all this actually ZigBee, Wi-Fi, LoRa, and Sigfox, it's license free. But if you wants to operate on cellular, then you have to pay a fee. This is also similar to narrowband IoT. So even though it belongs to low power wide area network, it is actually a part of cellular network. So you have to pay for the service. All right. So if you have like to cover a global customer with that can support very high data rate, then of course you need to somehow use satellite communication. And data protocol to ensure end-to-end communication over internet can be HTTP or HTTPS, MQTT, constrained application protocol, and so on. So this one actually, if somehow you want to know more, you can have a read, or you can actually take IoT class as well. Okay, so the evolution. Okay, the evolution in terms of cloud platform, you can see that before in the 1970s, there is a separate, system for information technology, between information technology and industrial automation. But as of 2000, there's already integrated architecture. And before actually, just 10 years back, the architecture actually still in a 5-layer architecture. So you have here enterprise resource planning, you have manufacturing execution system, you have supervisory control and data acquisition, then you have programmable line, programmable logic controller, input, output, and so on. So this is in 2010s. But now actually no more. There is a very weak differentiation between the layer. So there's no like this a pyramid layer anymore. So right now the layering actually it's very weak. It's not that clear anymore. So because why? Because we have the cloud platform right now. Due to this cloud platform, you can actually get rid the lower layer from the stack, PLC and discrete communication system here. So into the cloud, you can push the lower stacks into the cloud. So instead of 5-layer stack, right now you have edge to the cloud architecture. So you can enable edge to cloud architecture by bypassing the traditional 5-layer stack. So that is the future for IoT. Okay. So IoT connectivity changes the data collection system from on-premise to remote or cloud system. And the novel connectivity protocols allow the teams to achieve edge to cloud connectivity thanks to the advancement in computing hardware and software. So this is the example of IoT communication transport technologies. Okay, so I'm giving the benefits. Okay, the benefits. The spider web actually spell out the benefit for these 3 low power wide area network communication technologies, but long range. Why I said long range? Because for Wi-Fi actually, if you see here just now, because I think normally almost everybody hopefully knows what Wi-Fi is. It can cover up, the distance covered is about 1 kilometer, but this one you can see this technology can cover up with a single hop, can cover up to about 10 kilometer. Okay, 10 kilometer. Of course, it has its pros and cons, because you can see here, Sigfox supports very small data size, all right, and the LoRa actually higher data size, but the best will belong to narrowband IoT. So, if how to choose one over another, because basically they cover a very long range of data transmission in one hop, but the data support is very low. And then, so you have to decide as a system developer, which one to choose based on this criteria. If the range matters, then you want to choose Sigfox, because Sigfox ideally can cover up to 40 kilometers in one single hop. All right. And, but see the coverage here, the coverage is also very good. But you can see in terms of scalability is not that good compared to the other two, LoRa and also narrowband IoT. And then you can see also the payload length. It can only support very small data size, meaning that if like for agriculture, you want just to take, for example, the data on the pH of the soil, okay, and then you don't have to take it every hour. You can just take it like every day, once a day. So you might want to opt for Sigfox. All right. So and then it does not have a good quality of service, but because the application does not require it to have a very high quality of service. Say for just I mentioned just now, you want to take data on the pH of the soil, and then you don't have to take it continuously, just once a day or once every 2 days is enough. Okay, so this is what you want to opt for, the technology Sigfox, because the battery life and is very cost efficient and it's easy to deploy. So if you somehow wants to have like a higher data size, for example, you want to have like for smart metering, okay, smart metering. So you might want to opt for LoRa, because even though the range is lower than Sigfox, I think ideally it's about 20 kilometer. So it can support actually a higher payload, okay, a higher payload. And then the battery life and the cost efficiency is comparable to Sigfox. But the best, of course, is if you want to have very high quality of service and then a higher payload, is you opt for narrowband IoT. But narrowband IoT is not free, not like Sigfox and LoRaWAN. For narrowband IoT is part of cellular network, so you have to pay for the service, and the range covered is less. I think ideally it's about 10 kilometer. All right, but in terms of quality of service, this is the best. So it depends on you as a system developer, which communication technology you want to use as your transport system. Okay, so we have gone over the sensors, the things and the connectivity from the IoT ecosystem. What about the cloud platform? Okay, and its future directions. So IoT cloud platform is to create and manage application, to run analytics, and to store and secure data. Okay, so what do you think the cloud looks like? So Google search by image, oh, it's a cloud. Okay. So there are IoT platforms of every shape and size. So normally, cloud platform services should offer this service. Okay, ingesting, analyzing, interpreting the data at scale through cloud technologies and to generate some insights. So these are the some of the what you say required elements of a cloud service. It can support hardware integration. It can have it has some device management. Of course, it can support data collection, some rules engine to control device behavior. It can also integrate with like WebSocket data analytics, using the REST, the World Wide Web, using the REST protocol, and then you can carry out command execution, and of course connectivity to LoRa, Sigfox, and else. So for cloud platform, these services actually is a part of platform as a service. Okay, so you can see right now the market, if you are interested, which cloud platform is best suited for your application. So you can look at there are so many nowadays actually, because you can see that the market is growing. So they expect by 2023, the cloud platform market to, or the IoT platform market to reach about 22.3 billion USD. All right, and the leader as of now is the Microsoft. Okay, the Microsoft. So and then of course it has its own niche. Each cloud platform actually in the market has its own niche. So these are some of the niche: application enablement, cloud device management, connectivity, analytics, and the clients, the consumer of this market segment is manufacturing, and Asia will become the biggest region that somehow that adopts cloud platform in their manufacturing or in their business operation, right? So if you want to choose, since there are right now, the market right now is quite crowded with the cloud platform, you might want to somehow sift through the features that you want. All right, so you can have, for example, a cloud platform that has a building block stack, and then of course, some comes at very high pricing, some at low pricing, some are actually free. All right, but the ones that are free normally has limited features, okay, that I have to inform. All right, so which one you will choose depends on requirement. For just a prototype system, you might want to opt for the free system. If you are a company, then definitely you want to opt for the ones that are more established, like Amazon Web Services. Then you have IBM Watson, and then of course you can also have Microsoft Azure, and so on, right? So for the data, so right now, I said right now, IoT is not anymore in its initial definition. It must have some inference. How to do inference? You must have data collection first in order for you to do the inference. Before you you make some decision making. So managing and making sense of such data is essential if IoT solutions are to deliver value. Okay. So this is your machine learning system. You pour the data into this file of a linear algebra and then collect the answers on the other side. What if the answers are wrong? Just stir the pile until they start looking right. This is actually sort of true as well. The more data that you have, the more data that you train, then the better the prediction or decision making will be. Okay, so and in terms of analytics, it has it has stages as well. So at the bottom, you can see here, descriptive analytics. So this is the basic analytics where the point is, the reason is to ask what happened. All right. So if your system somehow can just do like, okay, how many entries per month or per day and so on, that is just to give a status of the system operation. So it's like using like bar charts and so on. So that is just descriptive analytics. So you get the information, but still it's better than nothing. All right. It's not just monitoring. At least you have some sort of information, basic information. So, but if your system can somehow do some diagnostic analytics, why it happened, then your system have knowledge. So if your system with the data available now, history data from the log data, it can predict what is likely to happen. Your system already has the third level of maturity of data analytics, which are predictive analytics. All right. So the highest stage of data analytics is prescriptive analytics, because at this point of time, you can have already your system knows what action to take in case anything happen. Okay, because your system already has a wisdom. So you can see the added value contribution increases as the level of analytics increases, but at the expense of higher complexity. Okay, higher complexity. So if your system somehow has as mentioned, statistical analysis, pie bar, histogram chart, scoreboard, you have descriptive analytics. So if you want to migrate to the second stage of in analytics, which is diagnostic analytics, your system must be able to do data discovery, data mining, drill down and through. And if you want to have predictive analytics, which many of you right now possibly might look forward to, your system might need to have some machine learning algorithm, regression, classification, and regression trees. So to proceed to the highest type of analytics, which is prescriptive analytics, your system must somehow has combinations of descriptive and also predictive features, and then it must have rules and optimization that leads to a decision algorithm. In short, it must have artificial intelligence. Okay, but do you think that many as a future directions of IoT, you think many systems have achieved prescriptive analytics? Sadly, it's not yet. Many systems has yet to reach prescriptive analytics because of these challenges. All right. One thing is security. So because we need for the system to reach prescriptive level, it must have lots of data, and then some companies actually are not willing to share the data because of security reason. So due to the lack of end-to-end security visibility, the service provider are quite reluctant to share their data. And also this actually the same thing, security and privacy compliance. So we because of this, actually, many companies are still quite reluctant. So that because right now we are moving, actually, we're looking at Internet of Data, and because of these issues, we do not have yet all the necessary data that we can somehow reach prescriptive analytics. Okay, so if you can see here, these challenges are quite the same: security and privacy compliance, lack of end-to-end security visibility, limited ability to detect and response to threat. So these three are all about security, and because of these three, many companies or many systems are yet to be friendly among themselves. All right, among organization, among the system themselves, because of this three. Okay, and then of course there are still systems that still deploy manual processes which are not scalable. So these are all challenges that still exist, that somehow avoid or somehow stop us from reaching up to the prescriptive analytics stage of data in IoT ecosystem. Okay. So right now, the future applications, as mentioned, when I say future application, it's very subjective. Some countries have reached this type of application, but others are still lagging behind. Malaysia possibly is in between, right? Can you hear it and the sound?
Yes, Prof. It's clear.
Smartphone, smart life. Not the smartphone. I will repeat. So you can just deploy sensors to detect if the fridge door is open. No need to switch on the lights. Once there's a motion detected, everything is automated, even the temperature for the shower and so on. Your fridge will also give you information what's lacking in your fridge. You have the mobile apps to wake up your son from his sleep. So you are also notified if your car is due for maintenance. They also estimate your arrival time at the office. So you must take off now. Gas sensor in the garage. Automated garage door. The fridge door is not closed well. Notification sent to your son's phone. Since nobody at home, change the temperature to for cost saving. Even at office, once they detect motion, everything is automated. Appointment schedule also will be sent. Your car also will advise you on the speed limit and so on. And this is before you reach the highest level of IoT maturity, where you don't even need to drive. You still need to drive, but your car is talking to you, giving you information. Okay, so if there is a visitor, repairman, we can actually allow the repairman to access your house for repair and so on. So I think you get the idea. Because of course this is actually achieved already possibly, but practically we still have issues with the service providers that are quite reluctant. So many of these solutions, actually IT solutions, are present in the market, but they are present in silos. They are not integrated. So we are using different solution for smart home. We are using different solution for our appointment mobile application. We are using so many solutions in silo. They are not integrated together. So in future, we want to have like one single platform for all these solutions, so that we can do network slicing for the respective use cases and industries. Okay, so but of course we must have all the service providers come together. All right, I think I will cut short the video. Okay, it's nearly over anyway. Okay, there's no more locking door manually. Your home will take care for everything for you. Right? Okay. Oh, okay. So this is another one, IoT in healthcare. So this is also a smart city scenario, the future of IoT. So if you have like elderly person somehow falls down, so the alert notification from her smartwatch is sent to the medical personnel, so that they can somehow uh, visit her or when go to rescue her. So once the ambulance take off, the ambulance will try to find the shortest route by connecting to the smart traffic light. And of course, because this ambulance needs to reach the incident location fast, it can also control the traffic light to turn green at every traffic light section, so that the assistant can somehow arrive in due time. All right, in due time. So this is the ideal case, of course. Right now we have to have many things integrated together, many providers to come together to provide this one single solution platform. Okay, and of course nowadays actually we even have smart agriculture where it's not about just human labor, but it's about using the drone. So in fact in Malaysia they already have some sort of regulation, documentation to use drone for agriculture. So because by using drone, some operation can be done by the drone and not by the workforce. Okay, and then by reducing the workforce, definitely you will be more cost, your operation will be more cost efficient. But of course it comes with still issues and challenges, where this solution from the mobile application for remote monitoring and control, from the IoT cloud platform, and then for the hardware to be deployed, they all must come together in one single solution. And also the government regulation, because in Malaysia, anything to do with drone, you need to permit to fly. So if you are a company that wants to deploy IoT smart agriculture, it will be quite it will incur high cost just to apply every time you need to fly the drone for the like spraying of pesticide and so on using drone. You need to apply for permit. So that means that you will incur higher costs, even though you reduce the workforce. it's sort of a trade-off. You incur higher costs because you need to pay for permit to fly. So all all those things must be considered, right? So I think I finished the part for future directions for IoT. So maybe before I start the second part, which is the introduction to my research group, or should I finish the introduction to my research group first, Ali? Before we
You
can
can
start with the
proceed. No
question.
problem.
Okay,
Yeah, you can
then
proceed. Yes.
I'll continue then.
Yeah, continue. Yes.
Right. So my research group is Telecommunication Software and System Research Group, and we are a research group that has a core, I couldn't see here. Basically, we have our research interest is on IoT. So we have somehow has a few IoT commercialized solutions already. So our IoT stories include the security solutions for guard patrol and SSS system. So you can see here right now, last time actually for security guard, they needs to carry a better light device to do the patrolling, and only they come back to the guard house and upload everything manually. But nowadays, no need for that anymore. We are in the IoT era or IR 4.0 era, where the patrolling, the checkpoints actually is in the form of RFID, NFC or geofencing checkpoints, and the guards does not carry any better light device anymore. They just carry a smartphone with the developed mobile application. So they can do their checkpoint scan during patrolling duties, and then all the data at every checkpoint will be uploaded in real time. No need to just go back to the house and upload everything manually. So besides that, because you carry the smartphone, so you can actually detect their you can do location tracking of your guards at all times in real time. So you know where they are and so on, because in every phone you have GPS tracking. All right. So besides that, we also have the smart barrier actually at the back, at the Senai entrance. There's already a prototype system of smart barrier where you have the IP camera, intercom, all integrated together. And of course, because all vehicles that UTM that enter UTM needs to have the stickers. So if you notice right now, the stickers, they have a RFID sticker. So if you have an official RFID sticker, so when you reach the smart barrier, because there is a NFC RFID reader there, the boom gate will open automatically. Okay, if not, you can also use your student card, because inside your student card there is NFC tag inside, so that you just scan your student card at the NFC reader, so that the boom gate also will open automatically. All right. So there are many sensors here and readers that somehow can allow you access. This is for the patrolling duties, online real-time data uploads, tracking of the guards and so on. And then we have actually on top of the ground patrol, now we also have even the drone patrol. Actually, will be we will mobilize aerial surveillance and patrolling soon. Actually, because right now we just wait for the permit to fly from the authorities, from the Malaysian authorities. Okay, as mentioned here, we have the security system. There will be drones for aerial patrol as well. And then for access door itself, some labs, if you can see at the entrance, actually SKE lab, there are system that you can access using your student card or your staff card. So that was developed, those systems, they was developed from my research group. Okay, this is the just now the patrolling the guard expert is the security patrol solution, where you can do the checkpoint scan just using the mobile application. Okay, so you can have real-time position monitoring. So when you have mobile application, you can build so many things. Panic alert, so the guard just can just press panic button if he's under attack, and then this will be shown at the the guard house, so that the location will be tagged together. There will be geotagging of the location, so they know where he is. And as long as you carry this handheld, the mobile device, we will know his location, the movement, so we can send help. In fact, if you press the panic button, the solution that we have right now, the drone will come. The drone will be the first emergency responder to, not for combat, to take the forensic evidence, what happened, and so on, to take pictures, right? So I just go very fast. I'm really sorry. So right now the indoor, so it's the same thing. It's a part of this solution actually. So under this security solution for the guard patrol and access, you can have the guard patrolling mobile application. You can have the smart barrier. You can have the access system. You can have the drones surveillance and patrol as well. That's why it says comprehensive. So, and if maybe you have some idea that can fall under this IoT-based security solution. Okay, so this is also a part of that security solution where this is for indoor, because GPS works only for outdoor. So for indoor, you have to use the means of tracking the guard's movement inside a building. So we use, in this case, our solution use Bluetooth low energy beacons. Okay, so this Bluetooth low energy beacons will provide the where the location of the guards inside an indoor environment. Okay, so the architecture is still the same. All the data captured will be sent to the cloud and will be displayed at the user end via web dashboard or mobile apps. Okay, so once you have everything web-based, you can monitor and see everything as long as you have internet connectivity in real time. Okay, as I said, UTM smart barrier at the Snai gate entrance. So you have long range RFID reader, you have camera here, you have intercom here. There's so many things happening and it's already installed. The prototype is already installed at the Snai gate. Okay, so this is some solutions for the lab access. So we have this installed already. Last time before the pandemic, it's been used constantly because the School of Electrical Engineering made a policy for all for the labs that operates 24-hour needs to have our system. So it's a homegrown system from our research group. So now actually we already migrate the system, not just using the student card, but we can also buy using face recognition. I think in lab, one of the lab already, I'm not sure whether it's my conductor lab or the SP lab. I can't remember. Already face recognition. Okay, and this is the dashboard. And then as mentioned, the drone for our security surveillance, we call it Jaga drone. So basically it will complement the ground patrol and surveillance. So because last time UTM is very large, so we have all the it's quite dense actually because there are many trees and so on, and it's quite dangerous for the guards to somehow do ground patrolling. So in some cases, the drone will be sent to do the surveillance. And I mentioned just now, if there's emergency cases when the guard press the panic button, the drone will be first to be mobilized autonomously. So the drone becomes the first emergency responder. Okay, so we have also asset tracking solution delivered to MMSG. This is Malaysian Marine and Heavy Engineering, where we delivered using RFID. This is the RFID that we designed with the casing to somehow help them to locate the spool. Spool actually a piping that MMSG actually is contracted to provide pipes for oil rigs, to build oil rigs for Petronas. All right, so they have a very large yard full of pipes, and it's very hard for them to find certain pipes that are needed. So by having this RFID tagging for each pipe, so and then mobile apps that we develop, so we use this mobile app to detect by communicating with this RFID tag. We can actually estimate where the pipes that is needed located, and then because in this RFID tagging, there are not just a passive RFID, it has also active RFID. So when we are near to the pipe that we want, the beep will become faster. So we know that we will know which one that we want. Okay, how do we know? Because of course we need to, the order needs to come in first, and once the order comes, we have to communicate with the database, the online database, to know the zone where it is, and then we can find it using the the handheld device with the mobile application that we develop. So this is the solution that they ask us to do, because normally when they want to find last time, because they don't have this RFID tagging, they have just a normal steel tagging. Sometimes it took them a month just to find a certain pipe, and then when they couldn't find it because the shipyard is very large, they need to refabricate. So they incur very high losses due to the refabrication, and when because sometimes those pipes also are being stolen. Okay. Okay, so this is warehouse management system that we delivered to Shimano. For this IoT solution, the same thing, we use RFID again. So the RFID tag will be installed at the pallet, and also RFID reader on the forklift or the reach truck. So the driver just needs to somehow pick up the pallet and read the tag, and we know the information, what's the cargo on this pallet and where it needs to be placed on the rack. And on the rack itself is another RFID tag. Only when there's a beeping sound, meaning that the RFID tagging matches, it is the correct location. Okay, so the movement of goods can be tracked in real time, shelf space can be managed more effectively, inventory control is improved, the amount of human involvement is reduced. We have many actually. So this is IoT-based queue management system that we developed for Al-Fateh printing. So if any of you actually do some printing at Al-Fateh company in Taman University, so we have developed a queue management system that is designed to help service provider to manage customer in an efficient way. Okay, so we have also developed apps for waste recycling and collection system. And then this is actually for Petronas. We work under a subcontractor because they have a solar panel on their oil rig, but they don't have a monitoring how much power has been captured by solar panel. So we help them by having a remote monitoring of the power or the energy, the solar power being captured on from the solar panel. So we have also IoT-based water monitoring system with the dashboard. Okay, and then the drone-assisted smart river monitoring solution. So last time, I'm not sure whether you are familiar with the incident happens at one of the river in Pasir Gudang, where it becomes too very polluted and the residents nearby got sick. So instead of sending like people to go for to check the conditions of the river, we can send drone. So it much safer. It is much safer with the sensors, that drone that carries the sensors, so that we will know the pH value of the river. Okay, so we also conduct some Internet of Things training. So some research, active research project, we have LoRa under our research group. We have also service-oriented middleware for home area network. We have also asset tracking, signal categorization for asset tracking industrial facilities. We have some image compression work also, and then microwave engineering research as well. And then we have also quality of service web-based software-defined network. So using reinforcement learning. So this is a type of machine learning. And then as mentioned, we have also research on drone technology in IT-based campus security solution. We have developed several solutions already. So you can come on board if you are interested to develop more. we are always welcome people that wants to work with us. Also machine learning assisted interference mitigation for wireless sensor network for IoT application, energy efficient in cognitive MANET IoT. And then this is an opening actually. We just one of our members just secure a grant on machine learning for environmental noise classification in smart cities. So, but unfortunately, we can actually provide allowance up to 2,000 ringgit per month. Starting this is we already had it. So if you want to start for the new semester next week, also possible. But unfortunately, it's for local students only. I'm really sorry about that because this is a national grant. So that's all from me. I think Ali, I pass the session to you.
Okay, Prof. Thank you so much. Okay, thank you very much to Prof. Associate Prof. Roziha Ahmed Rashid for her insightful sharing and great presentation. A short summary and conclusion for activities that Prof. Roziha has provided. Prof. Roziha has gave us a lot of knowledge and advice on the Internet of Things IoT, as it is a new paradigm that has changed the traditional way of living into a high-tech lifestyle, smart cities, smart homes, pollution control, energy saving, smart transportation, smart industries, and such transportation due to IoT. A lot of crucial research studies and investigations have been done to enhance the technologies through IoT. Also, Dr. Roziha has provided the understanding of IoT, its enabling technologies, future directions, applications, and challenges. Moreover, the importance of big data and its analysis with respect to IoT. The webinar was divided into two parts. The first part gives the introduction to IoT and the components that constitute to IoT environment. The second part of this webinar was the introduction to telecommunication software and system TESS research group, their IoT solutions and current research activities. Now it is the time to Q&A session, and after Q&A session, we will have group photo session. So please stay with us until the end of this session. And now let us start with Q&A session. Prof, can you stop sharing your slides? Let me share my slide. Can you see my slide, Prof?
Yes.
Yeah, Prof, the first question, what is the difference between IoT and industrial IoT?
Okay. Actually, the difference is just in the scale of implementation. Normally, if it says IoT, it means that IoT gadgets or IoT devices, sensors, smartphone, because smartphones is usually a sensing device. You have so many sensors inside the camera, accelerometer, and so on. But if you talk about industrial IoT, normally it applies to the application inside a large area in industries. Okay, so the scale, the difference I said is just the scale of implementation. So in terms of failure for IoT, normally the failure is for small population, but if you have industrial IoT, the failure will affect larger population. So that's what the difference between IoT and industrial IoT.
Second question, Prof. What are the economic impacts of the increased applications of IoT?
Many. As mentioned in the slides, you can have reduced labor, because due to the reduced workforce. Due to this reduced labor and workforce, you can have reduced time of execution, and due to this reduced time of execution or operation, you can have reduced costs. So there are many, I would say, economic impacts.
Okay. Another question, Prof. What are the challenges to the widespread use of IoT?
I also did mention this first,
Yeah.
security. Okay, security, privacy, so that stop the industries or the organization to work together into like uh, a single network or single platform IoT services. Of course, there are also cases for in some countries the infrastructure available as well. The infrastructure available, and then for a small and medium companies, in order to embark on IoT solution, they need capital as well. And government policies also are very much interrelated. So we in Malaysia, I'm not sure about other countries, but of course there are countries that don't have these obstacles or challenges. But in Malaysia, I think these challenges still exist.
Another question, Prof. What is the current job prospect in the field of IoT?
If you can just Google, if you Google actually the top 10 technology jobs trends in 2022, the number one from all three data analytics organization will be data scientists. Okay, but how does it relates to IoT? To get data, you need IoT platform. So if you have just the net, and then in order somehow to support this IoT platform and to establish communication, you need communication engineer or network engineer. So basically, if you studied in one of this line of in one of this field, basically, inshallah, because of the industrial revolution 4.0 and moving towards 5.0, this is basically the job trends that exist nowadays. Of course, for data scientists, this might be relevant to like big organizations like Huawei, Google, Facebook, Amazon, and so on. But for like smaller companies itself, data is actually, I would say, very valuable commodities, priceless commodities. Data is a priceless commodity. You can do so much with data, but you cannot just have data without having in the infrastructure to capture the data. So I would say the job prospect is very good for this field of work or field of study.
Okay, bro. Another question, what is the difference between IoT equal things plus sensor plus communication and your own formula, sense plus infer plus act?
Okay, so I will say, because I'm looking at the title of my my talk today, is future of engineering, right? So IoT says yes, things plus sensor plus communicate. That's the initial definitions of IoT. Where you just have sensors, you have sensors and things almost the same, but you have to have connectivity as well. So that will fall under communication features, I would say. But if you just stop there, you can just do monitoring. IoT ecosystem have evolved so much. So the future of IoT does not just stop there. You must have inference. Inference means you must have some sort of data analytics. And from this data analytics, only you can do informed decision making. Last time, decision making or the action that comes from the action is just from like manual action. You want to switch off, and without any, what you say, truth table. Truth table is data from your sensors. If this is 1, this is 0, what do you do? And so on. You just, okay, you look at there will be like, right now it's raining. So you want to switch off remote. You can do the switch remote control, but okay, you don't need to, you can stop the sprinkler and so on. But there is no informed, there is not informed decision making. There's just reactive action. So that's the difference. What you have, things plus sensor and plus communicate, is the initial definitions of IoT. Now, IoT is so much more. That is the formula for the present ecosystem of IoT, which is sense plus info plus act.
Okay. Another question, Prof. What are the opinion of some say that IoT will make a human laser and too dependent to the technology?
Okay, that's very hard because human factor is also very hard to judge. Because when you say lazy, I don't think so. For me, when you have something done automatically, you can spend more time doing something else. Like if you have your smart home doing many things like switch off on the light automatically and so on, you can go jogging, you can exercise, you can do other things. It does not make you lazier, but it makes you more competent in managing your lifestyle. It allows you to have to do something else, to do like to spend times for your hobbies, because other things are being taken care of automatically. I'm not sure. That's one of that's my thought. Of course, in some cases, how do you? I'm not sure whether it makes you lazy or not. I'm really not sure. I think with technology, it makes you much more stressful. In my case, not lazy. I think it makes me you are much stressful. If it things tends to break down electronically. So sometimes because of a dependency on this automation, it makes your life more stressful and not lazy. But I like to think positive that with these conveniences in your life, yeah, you can spend more times with your family to do to spend time on your hobbies and so on. That's my personal opinion.
Okay, Prof. Thank you so much. What are the attacks and vulnerability?
Many. Basically, I think IoT attacks is the same as cyber attacks. Okay, you can have man in the middle attacks. You can actually you can have attacks on the sensors itself. Attacks meaning that there will be a rogue sensor. It's not the sensor that belongs to your system. It's somebody else. I think if you watch many movies, the spy movies, you know how these attacks can be done. You can actually flood your IoT system with a virus, with Trojan, and so on, and with malware, and so on. So IoT system, because it's cyber physical system, as mentioned, it connects analog with digital platform. So the vulnerability is the same as any cyber vulnerability. It's the same. So we must put in place the security measures that you put in place in any cyber system as well.
Okay. Another question, Prof. What are IoT interoperability challenges?
I just mentioned right now, many solutions out there exist in silo. One thing, standards. Just now there's a cartoons, right? 14 standard. What? There are so many standards. So we must have a one standard for all. Then it becomes 15 standards. All right. So that's one challenges. Another is privacy security. So that's another challenges. There are many like what I said for some solution might still in manual processes, so it cannot be upscale. So those will contribute to the interoperability challenges.
Okay. What is the difference between RFID and IR? Can we call them sensors?
Okay. RFID is radio frequency identification. Okay, it is can be a sensor as well as can be also a wireless technology, because this is based on radio signals. All right. IR is infrared. That is a bit that is from a different type of technology, which is optical. Infrared comes from optical technology because it's optical sensor, while radio frequency identification sensor is based on radio signal technology. So it's two different wireless technology. One is optical from the light sensor. Infrared is light. It is produced. It can like you have LED. The light signal from there can be assumed as the infrared. If you have infrared sensor, it produce light signal, where RFID is radio signals. So both of them are sensors. RFID is very useful for tracking, okay, asset tracking. So because you can just have it's like put on a furniture or put on any asset, and if you have with you RFID reader, says like imagine yourself in a room, all right? In the room you have these tables, the chairs, the PCs, so you put RFID tags on all of them. If you hold RFID reader, you just need to somehow stay at the entrance of the room and you can just scan, okay, using the RFID reader, and it will list out in within its detection range all the RFID tags that it can read. Okay, so it's very convenient to have. So that's why it's very useful for asset tracking. Okay, and then for infrared, because it's optical sensor, so you need to find application that use optical sensors. Normally, I think for obstacle, like you have your TV remote, okay, that use infrared, okay, because you need to have when you wants to switch on your TV, okay, you can see that the remote there's a light at the end of your remote, so that is using the infrared signal. All right, so that is one application, and both of them, yes, both of them are sensors, but different type of sensors. I'm giving too long an answer. I hope everybody understands.
Okay, that's good, Prof. Thank you so much for that. Another question, Prof. How is IoT correctly related to the wireless sensor nodes, WSN, and what protocols are used?
Okay, from the presentation just now, from the slides, you can see that the sensors actually can be of, I hope you understand what physical sensors are. Temperature sensors. You have also, maybe because my talk is on the feature of engineering, so it's a bit advanced. So, but if you, normally I would start with the types of sensor you have: motion sensors, temperature sensors, pressure sensors. There's so many things. So even like if you have a touch screen, actually you have a pressure sensor, okay, on your screen. Okay, so there are so many sensors there. So these sensors, they have wireless communication module, meaning that the data that being captured, like temperature and can be sent with, once they integrate. I'm not sure whether you realize or not in the my slides just now. You have sensor integrated with sort of processor, and then there's also a communication module. All right. I can give one example, like if your temperature sensor you integrate with Raspberry Pi, Raspberry Pi as the processor, and also communication, because Raspberry Pi has Wi-Fi enabled feature. All right. So with that, actually, whatever you sense, then you can send the data wirelessly to through a gateway to be uploaded in a server, top server somewhere. All right. So that is wireless. What means wireless? Because you can capture the data and send the data wirelessly somewhere. Okay. To the sync node. We call sync node. The gateway is the sync node. All right. So that is wireless sensor nodes. But I think you want to ask about wireless sensor network. Okay, wireless sensor network is like, for example, if you like have like agriculture, okay, so you want to monitor the soil, the pH of the soil, or even the health of your plants, okay, of your for example, in a oil palm plantation. So you want to monitor the health of your oil palm, all right? So you put sensors all together, and then it will develop a network where all the data that you collected from all these oil palms will be sent to a signal to be signaled to a gateway to be sent to the outside world, to be monitored in real time through a web dashboard, for example. So normally wireless sensor network is at the edge computing part of the IoT. As mentioned, the IoT ecosystem, you have the things and connectivity, the cloud platform, and also you have enterprise application where you have enterprise application is the user end, where you have the web dashboard, you can monitor through your smartphone and so on. All right. So the wireless sensor networks falls under the things and connectivity at the edge part of the IoT ecosystem, edge network part of the IoT ecosystem, the things and the connectivity. Okay, the protocols are used depends because actually if you use like it's a for smart home, it's a wireless sensor network used in the smart home, so you might just use Zigbee as the communication, the transport protocol. If it used at a wider area, then and support more data, as mentioned in the slide just now, you want to use Wi-Fi transport protocol. So it depends actually on the application. So hope that answers the question.
Okay, thank you, bro. I think this is the last question. For the participants, if you have a direct question, you might unmute yourself and ask to the prof. You don't mind, bro?
The last question?
No, I mean for the participants, if you have any questions, you might unmute yourself and ask directly to the prof.
For the participants, thank you for listening. I'm sorry if I did not make my presentation clearer, but I hope from my presentation somehow excites you to know more about on our IoT.
Thank you, bro.
The future directions of IoT. Thank you.
I think this is the last question. Thank you again, Prof. Dr. Roziha Ahmed Rashid, for answering those questions and for the great presentation. It was a pleasure to have you with us. For the participants, be sure to fill in the feedback form. Please enter the correct details because we will use the details to record your attendance in the system, issue an e-certificate to you, and send you the slide through emails. Can Prof stop sharing? Or I have to stop?
Yeah, I already stopped sharing, I think.
I have to stop sharing so that we can have a group photo session. Okay. So dear participants, please turn on your video camera.
I can see Akram. Akram actually my PhD student. Akram, I hope you are doing well and progressing well in your PhD work.
Yes, thank you so much. I'm very happy to see you. Yes, I'm progress, doctor. And thank you for this very, informative session. It's very nice.
Thank
and
you,
all the
Akram.
best for you and for Ali as well.
Thank you. Also, we have Muhammad Qayyum with us.
Doctor,
Thank you.
Doctor.
Okay. Please open your camera, guys. Smile. Okay, you can see 1, 2. Another one.
Freestyle, Ali.
Yeah. One. Okay. 1, 2, 3. Okay. Another one, please. Because there are many here. Okay. Another one. 3, 2, 1. Okay. Thank you so much.
Thank you so much.
Once again, thank you so much, Prof. Roziha. And you may now leave the session early if you want. And for the community, they will contact you after this. Thank you so much, Prof.
Thank you.
Jazakallah khair.
Assalamualaikum.
Thank you so much, Professor.
Waalaikumsalam, Prof. Thank you.
Salam, Prof. Terima kasih, Prof.
Okay, for the participants, we have some announcement. Please fill in the attendance and feedback form. The link is in the chat window, or you may scan the QR code on the slide. You see it? Can you see my slide? And it will be direct you to the Google form. For UTM participants, note that we will use the form to record your attendance in the UTM ICAT system and issue an e-certificate for you through email. Non-UTM participants also will receive an e-certificate. So be sure to fill in the correct details. Make sure your name, matric number, and email are filled correctly in the correct column. So those are the coming structured course. Thank you all participants for your active participation. The community of postgraduate students society, School of Electrical Engineering, Pgss SKE, for the session 2021-2022 would like to thank you for your active participation in this online course. And we are encouraging you to keep participating in our future structured courses and talks we have planned for you. The upcoming structured course is how to publish high-impact papers, strategies, and insights. Don't miss the opportunity to improve your knowledge in publication in high-impact journals, strategy and tips for journal writing, submission and review process, tips and in addressing reviewers' comments, and strategy of writing review survey paper. The online event is on 20th of March, starting 2:30 p.m. to 4:30 p.m. You may scan the QR code on the session to register for Dr. Bruce. For future updates, you may like our Facebook page, UTMB GSS and join our Telegram channel. Thank you again for joining us today. Stay safe and healthy, and have a good day. Jazakumullah khairan all. For those who didn't fill in the form, please do so now. We are about to end the meeting within 1 minute. Inshallah.
I shall end the meeting right now. Okay. Okay. Goodbye, everyone. See you guys on next structure course.
Inshallah. Jazakumullah khairan.